Hey class, this is the last type of reaction for sheet number 7. This is double displacement. Just a quick review for types of reactions. Remember that we had, if you have an element plus an element before the arrow, that is definitely a synthesis reaction. If you have just one compound and then the arrow, or you have a compound plus heat, then what you have is a decomposition reaction. If you have an element plus an element, or I'm sorry, element plus a compound yields another element and compound on the other side, then that's single displacement. And if you have a compound plus a compound and then the arrow, that's our double displacement, the one that we're going to talk about today. So take a look at the pattern for a double displacement reaction. Here I have A and B together. A is the cation, B is the anion. So A is positive, B is negative. C is the cation and D is the anion. On the other side, what happens for a double displacement reaction is that we have B and D switching places. So A and D then go together and C and B go together. Notice with D and B switching places that we still have a plus minus and a plus minus, so these are ionic compounds. Okay, so why would a double displacement reaction, why would it work? Or why would B and D switch places? Well, either you're forming a solid or you're forming water. To understand this as to why you would be forming a solid, then you should know that most compounds, or a lot of compounds that are ionic, dissolve in water, such as you know that sodium chloride dissolves very much in water, and when it does, it goes from being a solid, which is what the S in between the parentheses means, to sodium chloride, and then we use what's called aqueous, or AQ, that's a Q there. That means that this right here is salt water, and this right here is table salt. Okay, so that's the difference between these two. Notice that they're both NaCl, and as a solid it's table salt, and as an aqueous solution it is salt water. Okay, so if we have aqueous solutions and we add them together and they don't produce a solid, then the double displacement doesn't work. It's a no reaction. So let's take a look at two examples, okay? Two examples of double displacement reaction working to produce either a solid or a no reaction. By the way, producing a solid is called a precipitation reaction. Precipitation not meant as in rain or snow, but as in meant as make solid. So a precipitation reaction in chemistry means you're making a solid. Okay, so how do we know if we're making a solid? Well, take a look at these four pieces to compounds. If we rearrange them and fit them on the other side and we come up with a combination that ends up producing a solid, then we have a reaction that works. Now I'm going to show you how to find out if we produce a solid. But first we're going to rearrange the reactants to make them look like products. Notice that Ag here is the positive part for my first compound, so that's the A. And then B is the NO3. C is the Na with a +1, and D is the Cl with a -1, okay? So here's what I do when I go to the other side. I'm going to write this out one time, and then I'm not going to do it after that. So the A, in this case, is Ag, silver, with a +1 charge, okay? The B is NO3, the polyatomic ion, and that has a -1 charge. The C is Na with a +1, and that has a +1 charge, and the D is Cl with a -1. Okay, so these are my ions that I'm going to switch around. Now the A doesn't move, the A stays still, and the D goes with the A. So that means I'm putting Ag with a +1 and Cl with a -1 together, and then plus, and then I go Cb. So the C is the Na with a +1 and the NO3 with a -1. Okay, so now that I have these together, I'm going to look at something called the solubility chart, and this is attached. This is part of the equation test sheet that I have attached to this assignment. So go back to the assignment and open that back up and follow along with what we have here. So the first one was the A and D was silver ion and chloride ion. So I go up here to silver ion, which is down here because S is silver, and these are put into like basically alphabetical by name. So silver ion, and then I go to chloride. Chloride is right here, and silver is right here, which means that I come down here to this S. S means solid. Okay, so if S means solid, then we have produced a solid, which is good news. So I come back here, and then that means that this is my solid here, and then I know that the reaction happens because I have produced a solid. So I go back and do my crisscross. Excuse me. I go back and do my crisscross. So the AgCl is my compound, and NaNO3 is my compound. Now it doesn't matter what this one is. This one actually ends up being soluble or aqueous, and I know that because of my solubility chart. So I take a look at my solubility chart here, and where's sodium? Sodium's right here, and I go to nitrate. Nitrate is right here. First of all, take a look at nitrate. Take a look at all of the AQs going down. There's not one single S there. That means if it's a nitrate, if the compound is or ends in nitrate, that it is not going to be a solid. So we know that going into it. That's not the only one. Take a look at sodium. Sodium going all the way across. There is no solid. They're all AQs. Okay, so there's a couple of them that do this. The group 1 metals do this, and there's a couple polyatomic ions that do this. You can take a look at, let's find another one that does that. Chlorate does the same. All the way down, it's all AQs or dashes. The dash and the AQ mean basically the same thing. It means that the compound, it says the compound doesn't exist or decomposes quickly. Okay, so let's go back here. Once we have our compounds written after the crisscross, so once we have the formulas correct, then we just simply step number 3. Then step 1 is writing symbols and charges in the correct order for the products. Step 2 is crisscrossing and of course checking to make sure that we have a solid. And then step 3 would be balancing. So I go back to balance. I got 1 Ag, 1 Ag, 1 NO3, 1 NO3, 1 Na, 1 Na, and 1 Cl, and 1 Cl. So the first example is already balanced. So let's go through the same process now with the second example. So the second example here has BaCl2. That means that my A is going to be Ba with a +2, because Ba has a +2. Cl has a -1, which is where that 2 comes from the crisscross, and that's the B. And then the C here is K with a +1, and the D is NO3 with a -1, like that. So when I mix them up and I do the other side here and I get A and D, that means I get Ba with a +2 and NO3 with a -1, okay? I already know I'm going to crisscross that and do that like that. So I come over here to the next one. The next one is K with a +1 and Cl with a -1. And I can crisscross that real easy. I can do that step super easy. I go back and check to see what I have for my solubility chart. So for Ba, I'm right here, so this is Ba. I go across to NO3. NO3 we know is one that does not produce a solid, so that's AQ. AQ for this one, okay? And then how about K and Cl? So where's K? K's right here. Okay, Cl is right here, so we take a look at this. This is another AQ. So that means that if both the products are AQ, that this is a no reaction, and I'm not even going to balance it. Okay, so the second one is a no reaction. No reaction because no solid is produced using the solubility chart. All right, I'm going to plow through this and keep going to the next one. The next one is even easier. Yes, easier. I still have my pattern of A, B, C, and D. I still have the pattern on the right-hand side of A, D, and C, and B. So I go through this. I got H plus and Cl minus For my A and B, I got Na plus and OH minus. And what you notice is that the first thing that I put together is the A and the D. And when I put the A and the D together, I get H plus and OH minus, which is the same thing as H2O. So we produced water. This is a neutralization reaction, which means that if I produce water, then it automatically happens. I don't have to look at any chart. I don't have to figure out any math or anything like that. So let's keep going. Na with a +1 is the C, and the B, the negative part for this, is the Cl with a -1. So I put my, I do my crisscross, and then I go back to balance. And because I go back to balance, and I'm going to get rid of the H2O because sometimes that gets confusing, I got one H on the left-hand side, one H on the right-hand side. I got one Cl, I got one Na, one Na, and one OH, and one OH. So that's already balanced. So that's an example of a neutralization reaction where I'm producing water, okay? Let's keep going. I still got A and B. This is a good example here because my A is still H+. That 2 actually comes from the crisscross from the sulfate ion. That's my B, and it has a -2. So these are the ions that I'm moving to the other side. This helps to solidify this idea in your head, okay, that we're moving the ions over, we're not moving the subscripts. The only subscripts that get moved over are with polyatomic ions like SO4. So on this side here, I got Mg with a +2, and the D is an OH with a -1. So when I move A and D together, notice again, I'm moving H plus and OH minus like this. And then I go plus, so this is A and D, like that. Okay, now obviously this is going to be HOH, which is the same thing as H2O. So my C and D then is magnesium. Magnesium has a +2, and my sulfate is B, and that's a -2. And because they're a +2, -2, you can cancel them like that. +2, -2 cancels. So the only thing I need to do is check to see if I made water, which I did, and now I can balance the equation and be finished with it. So let's go back here. Notice I have 2 hydroxides here. I only have 1 here, so I put a 2 in front of the whole thing, like that. I have 2 hydrogens on the right-hand side. I have 2 on the left-hand side, so that balances. I have 1 SO4 and 1 SO4. If I had more than 1 SO4, you would see parentheses. So I have 1 Mg and 1 Mg. So now I'm balanced just by putting a 2 in front of the H2O on the right-hand side. Okay, let's take a look at one example of each. So here is A, and B, C, and D. So A goes with D on the other side. So this is Al with a +3 and Cl with a -1. Now, do we have a precipitation reaction or do we have a neutralization reaction is the question. Here I have a plus, a hydrogen, so this right here is an acid, and this ends in OH, so that makes this thing a base right here. So here I have an acid-base reaction. Okay, so that means on the other side over here, I got H plus and OH minus. So notice that if I produce HOH, that this is going to automatically work, and then I can go back through and crisscross. I crisscross to get AlCl3. I hope we're getting better at the crisscross with the ionic compounds, like that. So AlCl3 plus HOH, and then all I have to do, because I know this works because of the water on the right-hand side, I just have to go back and balance. And to balance this equation, I take a look at the ALs. I start on the left-hand side. Al, 1 Al, 1 Al, 3 OHs, and only 1 OH here, or I would see a parenthesis, so I put a 3 in front of the whole compound to get 3 H's. I have 1 H on the left-hand side and 3 on the right-hand side now, so I put a 3 in front to get 3 H's and 3 Cl's, and I have 3 Cl's on the right-hand side. I'm sorry I went through that pretty quickly, but the balancing part here you guys are actually pretty good at, so I don't think I'm confusing anybody by rushing the balancing part a little bit. Let's do one example with There we go. Why don't we do this one for letter A? This is aluminum nitrate. So this is A here. Aluminum is a +3. Nitrate is NO3 with a -1. Okay, and that's my B. My C is ammonium, NH4 with a +1, and hydroxide like this with a -1. Okay, now what kind of oh, that's my D. There we go, like that. So I'm going to give myself a little bit more room by pulling this down. Poop, I don't have much room here. So I'm going to erase this and make my compounds. That's actually pretty easy to do. I do my Al, NO3, 3 like that. And then I'm going to make that compound there. So this is going to be plus NH4OH. Now this looks like it could possibly be a neutralization reaction because of the base there, NH4OH. But it's not because Al does not make an acid, only H does in front. So this must be a precipitation reaction. So let's go through and see if we can get the A, the B, the C, and the D. So the A is Al with a +3, and the D is an OH with a -1. Okay, so on the right-hand side, for the next part, the C, this is A, by the way, and this is D. And my C and B is NH4, there we go, with a +1, and NO3 with a -1. Okay, so let's check the sheet. What do we have here for, I want to get back to here. So because this has to be, well, first of all, here's what we know. We know that NH4 here is another one that is all aqueous all the way across. So let's check for aluminum. Aluminum and hydroxide, there is my solid. So there's aluminum, the one right above the ammonium, and there's my hydroxide, and notice I have a solid, which is fantastic because that means this reaction actually works. So my solid is on the right-hand side, that's aluminum hydroxide. I can complete this equation. I'm going to erase a couple of things here so I can do my crisscross. I put my solid in here like that. That means I identify the one that turns solid because it helps me. And then I get rid of this stuff here like this, and I do my parentheses and my 3, and that all got very jumbled. So I'm going to rewrite the whole thing here. AlOH3, there's a plus there, and there's my solid. Okay, I'm going to move this one over a little bit. Nope, okay. Oh, you are killing me. Absolutely killing me. NH4, NO3, like that. Okay, so now all I have to do, once I've identified the solid, is finish the reaction by balancing it. And I got 3 NO3s over here and only 1 over here because there's no parentheses. So I put a 3 in front for my NH4NO3. That gives me 3 NH4s. So I put a 3 in front here to give me 3 NH4OHs. I have 3 OHs here and 3 OHs here, so that works, 1 Al and 1 Al. Okay, so that's it. And we're all balanced. That's a 1-3-1-3 reaction. Notice the solid. Okay, thank you guys for paying attention. Good luck.